What's cracking, guys? Chrissy here, Crystal, whatever you want to call me. I am back with another video, and this time it is, you guessed it, based off of the title, it is science-based video. Now, what we're missing in the niche of YouTuber fitness gurus is a lot of science. We got a lot of bro science. Don't get me wrong, we got a lot of bro science. I can think of like 10 off the top of my head. Yeah, that's a lot of bro science. But we are going to talk about evidence-based fitness. So, first I want to start this video off saying I am in no way or shape, form affiliated with Gymshark, and also my dog was real cute. She gonna be hanging out with us, you know what I'm saying? And then second of all, I do want to disclaim that I am going into my final year of studies in honors life sciences at McMaster University, so I do have a little bit of knowledge when it comes to applying it and reading papers and taking away information from papers that is viable, statistically significant, which is something I'm going to emphasize a lot in this video, and applicable to what we're discussing. So I just wanted to throw all that out there. So let's start. Girl, she leaned against me. Regardless, okay, I'm gonna stop being distracted. Let's start off this video with our first paper. So I'm gonna discuss a little bit in depth, and then we're gonna go on to like more broad overviews. Before we get anything else out of the way, this video is on the effects of exercise as it applies to the immune system. So what effects does exercise have on the immune system, and how does the immune system also affect the way we exercise and the development of our muscles? You know what I'm saying? Why you no flex? My biceps hurt. So the first paper we're going to be talking about is, and I have it right here, T-cell activation and proliferation following acute exercise in human subjects is altered by storage conditions and mitogen selection, which means that basically T-cells are proliferating, and these T-cell proliferations are dependent on what's present in the body at the time of acute exercise. So, where was this paper done? This paper was done at the University of Creighton University, Creighton, I don't know if I'm pronouncing that properly, in the Department of Exercise Science and Pre-Health Professions, as well as the Department of Molecular Biosciences at the University of Kansas. And it was done by Gallagher et al. In 2017, so it is a fairly recent paper. I think they submitted in April, so it's not even that old. Not that old. Okay, so what they did was they had 6 healthy males for the study who were trained individuals. So what they found was that their average 1 mile run was 5 minutes and 58 seconds, plus or minus. We call this the standard deviation of 40 seconds. And their average 1 rep max back squat was 167 kilograms. So they were fairly strong individuals. They're about 340 pounds. Plus or minus 42 kilograms. So some participants had 42 kilograms less, some had 42 kilograms more. But that was just like the average. And then the subjects self-reported that they spent 2.5 plus or minus 2.2 hours of aerobic exercise per week training, and then 4.2 plus or minus 2.5 hours of resistance training per week. So all of these studies were tested in the morning because upon waking you have a different metabolic and hormonal profile versus throughout the day, because you're unfed, you're just waking up from rest, and your hormones haven't really been, they've been dormant they've been working overnight, but the hormones that are dependent on your blood glucose levels and your blood sugar levels were not being active. So it's the most accurate way of measuring something. So what they did was they tested these 6 individuals, and they had them do 30 minutes of exercise every morning. The first exercise was as many reps as possible as a back squat at 62 kilograms. Then it was body weight pull-ups, as many reps as possible, as well as body weight dips. So tricep dips, as many reps as possible. And the as many reps as possible went up to maximum of 25 reps, just to save time. They measured the rating of perceived exertion, which is a measurement on a scale that measures how exerted you feel. So it's based on a set number of criteria, and then they were aiming for a rate of perceived exertion between 15 and 16 for each individual, so they knew that the acute stress placed on the athlete during the exercise was strong enough so that it would yield significant results. And this is on the Borg scale. And they measured this every 3 minutes. So they measured it 3 minutes, 6 minutes, 9 minutes, 12 minutes, and 15 minutes. And they did give a 3-minute rest between the 15 minutes of treadmill and beginning the circuit resistance training. And then there was a minute between every set of the circuits, I believe. Or sorry, 3 minutes between every set of the circuits. And then they also did a control measurement as well. And this was just 30 minutes upon waking, coming in, sitting in a room, doing absolutely nothing. You can't sleep, you can't go on your phone, you can't talk. Like, you were just sitting there, resting, doing absolutely nothing. So they had a group that was at rest for 30 minutes in the morning, and then they had a group that was acutely exercising and reaching a rating of perceived exertion that they were trying to reach. So they did a couple of different measurements, as you know. They did a rating of perceived exertion, and then they also measured their heart rate using an ECG. It was a 12-point ECG, which is what you typically will use when you're in the hospital. So it goes here, 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 3 on the stomach, and there were a couple elsewhere. I can't remember exactly where they go. But what they were trying to do is that they were trying to measure the heart rate at different intervals and in different zones to see how long they stayed within those zones throughout the workout, as well as seeing if they're all hitting the same zones at the same time, just so there's a little bit of a linear progression for all of them into their certain heart rate zones. And then following these measurements, after the exercise, after every instance, they did take blood. And what they did was they tested the T cells with CD3 antibody, which means that they're testing that the T cells are viable T cells that express CD3, because any T cell in your body, which is an immune cell, has to express CD3 in order to be viable, as well as testing CD28, which is a co-stimulatory molecule, which actually activates the T cell and drives T cells to expand and create more T cells. So the results are as follows. They found that the average heart rate during the trial was approximately 150 beats per minute, as well as it had a deviation of 15 beats per minute. So it ranged between 135 beats per minute and 165 beats per minute. And their predicted heart rate was actually that they would all be within 190 beats per minute plus or minus 3 beats per minute. So they were off a little bit in their prediction. And then the resting control heart rate was 79 beats per minute plus or minus 7 beats per minute, which is a pretty decent at-rest heart rate. And I'll just put on the screen, because I don't want to go into this in too depth of detail, is the time spent in different zones. And what you can see is that a majority of the time was spent in zone 5, so the higher exertion zone. And then I'll just circle that on the screen as well. So what they found when they did an analysis of the blood was that exercise truly did drive T cell proliferation, and it was dependent on the mitogens that they used. So there's different mitogens you can use. One is PHA, and they found that with PHA there was a significantly higher driving force of T cell proliferation than when using, I believe it was a CD28 and CD3. And these differences were a little bit different, but not so different that it was significant. And then what they also found that the T cell proliferation capability immediately after exercise, it was more proliferative capable, so it was able to proliferate more after exercise than if it was let to rest overnight for 24 hours. So it would be the same sample with the same conditions, given the same mitogens or cell division driving factors as the samples that they would test immediately after exercise, but the proliferative capability would not be as strong, which shows that there is some factors activating within the blood that are being created or released by surrounding cells during bouts of acute exercise. So we see that immunity actually almost increases during exercise. And basically what all that fancy stuff means is that if you exercise, you are actually driving your immune cells to differentiate and proliferate, which means that you are increasing your immunity. So it goes to show that even 30 minutes of exercise per day does drive immunity. Now, this isn't 100% confirmed, it just suggests it. So until we can fully prove it through seeing what types of T cells are differentiating, whether they're T cells specific to certain antigens or just circulating T cells that haven't matured yet and aren't actually activated, as we like to say, it still goes to show that you are increasing your T cell population or your immune cell population after acute bouts of exercise, which is super cool. So another study I looked into was called the elevated salivary IgA, decreased anxiety and altered oral microbiome is associated with active participation on an undergraduate athletic team. So what they did was they took two teams. They took a soccer team and a hockey team. We're just gonna refer to them as on-season and off-season because I don't wanna keep track of that. And they were either in season, actively participating in sports and training, or they were in off-season and just doing normal student things. And all of these are student teams. So like I said, I didn't want to go too much in depth, but what they did was they measured IgA, which is an antibody found in your mouth, and it binds to mucosal surfaces. So in your mouth, you have salivary glands and you have a mucosal surface that protects your mouth and also houses microbiota, which are bacteria. And dependent on the type of bacteria you have in your mouth, you could either have a healthy mouth or a not so healthy mouth. So what they found in this study, when they measured the types of bacteria in your mouth, they found that elite athletes who were in season had less bad bacteria, which contribute to periodontal disease, which basically means it gives you gum disease and rots your teeth, than their off-season counterparts. Furthermore, they found that the mucosal surfaces had way more IgA antibody. And when you have high levels of IgA antibody, this means that you have a very strong mucosal immune system. It's the first line of defense when you are battering off certain bacteria, like you get herpes or something. You're less likely to get herpes if you have higher IgA levels because it will recognize the herpes virus and it will bind to it and make sure that it doesn't get into your cells. So basically what they found is that they also have very strong antibody levels in their mouths, which is super cool. So it shows that there is a higher level of immunity. And also they measured the microbiota in general, just the general population, and they found that there were significantly more and statistically significantly more microbiota in the in-season athlete's mouth compared to the off-season's athlete's mouth. So basically what this means is that they have healthier microbiomes. We don't know if they have more diversity per se, but we do know that they have more bacteria, more good bacteria. So it means that they are more well protected because this microbiome, not only does it keep your mouth healthy by secreting certain factors and oils, like the bacteria will secrete certain factors and oils, they also secrete antibiotics, natural antibiotics, as well as these things we call proteases, which degrade bad bacteria. So bacteria that are not commensal or that are not symbiotic, and it's super cool. And finally, they also found that the cortisol levels in these athletes and their GAD-7 score, which is a generalized anxiety disorder survey, was much lower than their off-season counterparts. Now, maybe the data doesn't suggest that there's a direct correlation between an in-season athlete versus being an off-season athlete, because even though their cortisol levels and GAD-7 scores were statistically significant comparing to each other, they weren't statistically significant compared to their off-season counterparts. But there are some limitations to this study which could influence the data that we're seeing. The first limitation is that there is camaraderie in athletes. Now, if you're off season and you're not hanging out with your teammates so much and you're not going to tournaments, you're not getting hyped up and you don't have banquets, then maybe you have more anxiety and maybe you're more stressed out because you don't have socialization in your life, as much socialization as you would on a team. And they found in previous studies that being on a team does level general anxiety, as well as lowers the level of cortisol in your blood. That's just one of the things. Another thing could be that there are training differences between the two teams, but we don't know if the off-season team wasn't training as much as the in-season team. So that's also another limitation. Another limitation is that this may be specific to students who aren't competing at elite levels. Now, why we say elite levels is that Olympic athletes have different training regimens than a varsity team in college or university. So these statistics may be specific to students only. So another thing might be that student athletes, because they are already so busy, they might have better time management skills than student athletes who are in their off season. So basically what this means is that because they're so busy and because they have to manage their schedule to get everything done, they may already have less anxiety because of that. Regardless, this study shows that you can be a very high intensity training athlete, and it shows some really significant immune benefits as well as stress benefits, which I think is pretty cool. Another study that was done, I'm just gonna briefly go over this because I kind of touched on it a little bit earlier with the cortisol talk, was that they found that exercise slows down the release of the cortisol hormone, and cortisol is known to be immunosuppressive. So I'm just gonna throw it up right here and you can see the little pathway. So what this basically shows is that when glucocorticoids or cortisol is released, we see a decrease in immune function. Okay guys, well that's basically all I have for you today. I do have a little bit more, but we're running a little short on time. So if you want to see another video, if you want to see part 2, remember to hit that thumbs up button and comment down below about what you thought was cool about this video. And if you have any questions that you'd like me to answer, scientific based, just throw it down in the comments below. Like, I'd be so happy to answer it. And like I said, my name is Crystal Savin. I hope you liked it. Don't forget to like, comment, subscribe, do the thing. Repeating myself, and we'll see you in the next video. Thanks guys.